since the beginning of time. Some ancient mysteries have never been solved. To take an unforgettable journey where no one has dared to go for thousands of years.
In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
They roam the planetary surface, fly underwater, and soar through the heavens. But this is no wildlife safari on planet Earth. This is an expedition of astronomical proportions.
Everything looks good from here.
Okay, we copy that.
When the human race discovers it is not alone, what will our cosmic brothers and sisters look like? To answer this question, leading astronomers and astrobiologists have applied the principles of evolution and physics to 5 types of alien worlds likely to be found in the cosmos. These are the creatures that could be out there. Prepare to take an intergalactic safari and peer directly into the eyes of alien faces. The universe. An intergalactic sanctuary of billions of galaxies and trillions of stars. Could it only be a lifeless, barren wasteland of gamma-ray bursts, burning stars, and black holes? Or does life exist beyond Earth in this cosmic paradise? Do alien faces gaze towards us, pondering the age-old question, are we alone? Scientists are still searching for the first signs of life beyond our planet, but many are convinced it's out there, waiting for us to find it. But what on earth, if anything, would it look like? With a potent mix of earth science, logic, and the theory of evolution, computer graphic artists are able to bring some of these alien faces to life. And to come face to face with these extraterrestrial creations, we will embark on a fantasy safari through the unexplored reaches of the universe, like a tourist in an intergalactic zoo. Our first stop, the theoretical planet Aranel.
The planet Aranel is an odd planet. First of all, it doesn't circle around a star like our sun. It circles around a little red dwarf. These are tiny stars. They're sometimes a fifth, a sixth the size of our sun. So the habitable zone is going to be much closer to that star.
This habitable zone is a crucial piece of the puzzle when understanding the evolution of life on any alien planet.
A habitable zone in a solar system is the distance from the star where water can exist as a liquid on the surface. It gets enough heat energy from the star to have liquid water and stay liquid water.
liquid water is one of the basic elements for life to begin. But on Arenal, the habitable zone is so close to this glowing ball of burning gas, the star's gravity causes Arenal to be tidally locked, much like Earth's moon, as we only see one side of the lunar surface at all times. This would mean that half of Arenal is constantly in daylight, and the other half is constantly in darkness. In the middle, there would be a 200-mile wide area that stretches from the North Pole to the South Pole, which is in a constant state of twilight.
So it makes you wonder, where would we find life on this planet? Well, truthfully, you're going to find it everywhere. But if it's on the dark side, it's life that's been adapted for living in the dark. And if it's on the bright side, it's life that's been adapted for living only in the bright side. And in this twilight zone area, you're going to find creatures that are adapted for both. They can wander and stray into both sides on this world. They really control their own destinies in where they want to go and where they want to hunt.
On Arenal, you're going to have a photosynthetic organism, probably likely in the marine environment, a red alga, or a bacteria that will be adapted to taking in infrared light and taking what energy it can out of that and making food. On land, it would probably be a lichen-like thing because it's cold, mosses that would be adapted that way. You're going to have organisms that are going to feed off those.
This algae on Arenal represents the bottom of a very long food chain. Everything plays a vital role for survival, from the plant life to the larger, more complex creatures. One example on Arenal that uses this algae as a food source is the insect known as an acom.
The acoms are a bizarre little creature. On Earth, we know of what we call metamorphosis. It's the odd ability of a creature to change from one shape to another. We see it in butterflies. A caterpillar eating in your garden will climb up on the fence, spin a cocoon, months later hatch out into a butterfly. These do that too, but they do it in a very odd way. They look almost eel-like with two sets of fins that stick out on either side. At some peculiar moment, they move over to some of the plant life, lock themselves in, and attach themselves and form a shell around them. When that shell splits, out comes something that we've never seen before. Taking the hydrogen from the water, splitting the hydrogen from the oxygen, it inflates a little bubble, and they lift right out of the water. The breeze is picking them up, carrying them to high altitudes, spreading them out over the planet towards the twilight zones as the breezes move. And they're almost like parachutists coming back down.
Once the acoms reach the ground, they immediately create a burrow where they primarily live. But as the acoms scavenge through the dirt for food, they're hunted from above by one of the next links in the food chain, the penapod.
Now, one of the creatures that we'd find most interesting on this world is the penapod. It's an odd little creature because its eyes wrap all the way around so it can see any movement behind it.
In the twilight zone of Arenal, it is going to be very dark and cold due to the low light of its star. And the hunters, or even the hunted, will have developed large eyes like owls or other nocturnal creatures here on Earth. But there's an interesting adaptation that developed in most creatures on Arenal.
Arenal orbits an M star. M stars emit most of their light in infrared. Infrared is the light that, it's actually heat that you feel when you open up the oven. That's what these creatures would see. They would see the heat expended by their bodies in the world around them. It would look very different than it does to you or me.
To see heat signatures on the dark side of the planet is one of the biggest links on the food chain of Arenal. The Kurja, a cunning advantage.
They're, in their sense, in their moves, in the way they act together, they resemble jackals in the plains of Africa. They move in herds, they're hunters, they're predators. ugly little nasty creatures that will surround a peanut pod or a colony of them, ferret them out, and that's their meal. They have the odd ability, however, to see not only in the twilight regions with eyes like we might normally have, but they have a second set of smaller eyes right above that once they move into the darker regions, the nighttime side, they can now pick up the heat signatures of creatures in that area.
These are only a few of the creatures that could live on a planet like Arenal. But at least for now, they are simply a product of our imagination.
In science, we can sit there and we can imagine life elsewhere. But if we have examples, we have one data point, in fact, and that's planet Earth. And so if we can look at life on Earth, it provides us with an amazing wealth of information that we can then take forward to look for life elsewhere.
We have a variety of ecosystems that we can study, and we can look at challenges. What are in ecosystems? What challenges do living things face? And we can apply these principles to alien life.
To understand how these principles can be applied, we must continue our intergalactic fantasy safari. We leave the surface of Arenal and zip across the cosmos 322 light years away to a new solar system and the theoretical planet AG-143.
AG-143 is bigger than the Earth, much bigger than the Earth. It has a beautiful ring system that circles around it. But more importantly, it is a big, gigantic, dry desert with 3 times the gravitational field that we feel here on the Earth.
A human weighing in at 175 pounds on Earth would step off onto the surface of AG-143 to weigh about 525 pounds. Certainly, life would need to adapt. But how? David Aguilar of Harvard University's Center for Astrophysics believes the best way to envision the adaptations of complex alien life forms is by looking at the variety of creatures that have evolved to inhabit the diverse ecosystems of our own world.
We're here at the North Carolina Zoo because of all the zoos in the country right now, this is very special. It is large. It's big. And the environments here duplicate the different environments we find on our planet. This here today is a marvelous example of the variety of life on our planet.
And within this variety of life on Earth, Aguilar believes that creatures supporting an extremely heavy structure become the perfect model for understanding evolution on AG-143.
When we talk about an animal adapted for a heavy world environment, a world with more gravity, this is it. Look at what we have out here, the prototype legs that can suspend a huge body. Of course, we would have to move him down, move him closer to the ground, but this is perfect what we would see. Shorter, squattier, but heavy like this, adapted to a planet with much stronger gravity.
Although life forms on AG-143 have certain comparable characteristics to creatures on Earth, their alien faces are beyond anything found on our planet.
Everything looks good from here.
Okay, we copy that. Sounds good.
We wish we were with you.
What if, one day, a deep space probe detects life outside our solar system? What would an alien look like? To better understand these otherworldly creatures and how they might have evolved, scientists believe you must first understand a few simple concepts about the physical environments where life might begin.
When looking at planets around distant stars, there are two factors that we scientists zero in on. First is distance to the mother star. That determines how much energy you have and whether or not you have liquid water. Second, the mass, the size of the planet. That determines gravity and what kind of organisms you may have.
When people think about evolutionary biology, we tend to think of the whole nature red in tooth and claw, the whole Darwinian competition among organisms and among species and so on, but we forget that it's the physical environment that really shapes life. What gravity you have, what temperature, what pressure, what composition the atmosphere is, if there is any atmosphere, and so on.
The laws of physics don't change as you travel through the universe. So understanding how creatures evolved in our earthly environment has allowed scientists to imagine what life forms might arise on other types of worlds, like the theoretical planet AG-143. AG-143 orbits a bright F-class star. Only 10% of this world is covered with surface water, and pockets of this liquid H2O collect under the sands from sparse rainfall. The environment on AG-143 is hot, arid, and the sunshine extremely bright.
Now, because the star is an F-class star, okay, which is brighter than the sun, you're going to have UV output, ultraviolet light output. So, the organisms there are going to have to somehow be shielded either in the atmosphere or in their own coverings.
These coverings may be in the form of thick shells or other exteriors that would absorb the harsh UV radiation. But the creatures on AG-143 would also develop other physical characteristics that are unique to this world.
It's really interesting to imagine what life might be like on a planet with higher gravity. Well, from a microbe's point of view, there might not be a whole lot of difference. Where the differences would start to come is when you go out and land, for example, and there you have to worry about standing up. Oh, darn gravity, you know, I just can't pull myself up.
But another byproduct of strong gravity may also give rise to an unlikely cast of characters on the surface of AG-143. Or rather, slightly above the surface. On Earth, our atmosphere is 79% nitrogen, 20% oxygen, and 1% other gases that is held in place due to the gravitational pull of the Earth. But on a planet like AG-143, the stronger gravity would hold a much thicker atmosphere, perfect for achieving flight. It may also hold a much higher level of oxygen.
We went through a period a couple of 100 million years ago where we think the Earth had a higher concentration of oxygen for a while. And what we see in the fossil record is giant insects, huge wings, giant flying organisms, because if you think about it, you have more oxygen for metabolism, so you can do things with more energy. It's like taking in a higher oxygen with an oxygen tank or something, and you feel all pumped up. And that's how these organisms must have felt.
With a thicker atmosphere and higher concentration of oxygen, the skies of AG-143 would be full of large flying creatures that could stay airborne for as long as they need. One example could be the sargon. This creature would live most of its life soaring through the atmosphere, looking for pockets of water that scarcely pepper the planet. Once the sargon finds a watering hole, they swoop down in hopes to not only drink, but hunt any creatures that may have found their way to the oasis. A creature like the moblant.
At first sight, you might almost mistake a moblot for a starfish. It has stubby little arms that it moves across the desert. But the odd thing about these arms is they have long tentacles that probe the sand for pockets of precious water that may be hidden. And the odd thing about this creature is if it finds a large pocket of water, It begins pulling the water up like it's pulling it up a well. And it grows in size, and it grows in size, and stores the water up like a camel does.
Adaptations to locate and store water are crucial for survival. To be stuck out in the middle of a desert, hundreds of miles from anything resembling a liquid, would be a death sentence for almost any Earth creature. The same would be true for life on our theoretical planet AG-143. This is why the Pholus lives primarily near the water deposits, so that it will remain close to this precious commodity.
One of the most bizarre creatures on AG-143 is the Pholus. They're short, squatty. It's a mouth supported by 3 legs on a pedestal platform that has scales underneath. It glides across the sand almost like a sidewinder as it moves. It has the uncanny ability to sense chemically whether or not its prey is nearby. It hunts around the edges of streams and small little lakes, and if it finds its prey, it suddenly stops, freezes, and camouflages itself so that it almost becomes invisible, waiting. Until a hapless creature moves and then suddenly, out it snaps. It's found its dinner.
And the Pholus's method of movement, gliding across the surface like a snake on grass, is another evolutionary characteristic caused by the stronger gravity of the planet. To slide with scales rather than lifting a leg would be a lot easier for any creature. That, and it offers a quiet advantage over its prey. They may never hear the Pholus coming. But as the food chain goes on AG-143, nothing is safe. For lurking in these pools of water lies a silent but deadly creature known as the Heathor. As we end our examination of the food chain on AG-143, we've seen the extreme challenges that creatures on a world with little surface water and higher gravity must overcome. But what if the planetary conditions were reversed? What if a planet had a suitable amount of water for life, but also a much weaker gravitational force? The answer might lie right above our heads, in the skies above the Earth. On our intergalactic safari, we've seen how leading astrobiologists used present-day Earth science to hypothesize about the size, shape, and behavior of creatures on an imaginary world with much stronger gravity than Earth. But what would happen if the gravity was much weaker? To find out, we lift off from the strong gravity of AG-143 to another planet 89 light-years away, GPC 925.
GPC 925 is smaller than the Earth. It's about half the size of the Earth. It's borderline for an Earth-like planet. And because it's smaller, it has less gravity. The star that it circles around is cooler than our sun, and because of that, it's a cross between frozen ice patches, green photosynthetic plants peeking through, and some bodies of water. It would look very much like the northern part of our planet. You get up towards the northern parts of Canada and Greenland. We call it the taiga areas. GPC 925 would be a very specific type of environment. You wouldn't find deserts on this world. You would find very few mountains actually on this world. It would be a world that was cooler, more preserved than what we see on our own planet. But beautiful just the same.
This world with much lower gravity could generate much larger, more elegant life forms. You know, I'm 6'6". Imagine how tall I could be if I had evolved in a world with a half or a third the gravity. Imagine what a redwood would look like in a world with lower gravity.
These types of gravitational effects on the surface life would shape and model different characteristics. It would also appear that on a world like GPC 925, much of that surface life would not be found on the surface at all.
Here we are in the aviary. Up in these trees are the remnants of the dinosaurs. This is what was left behind when the dinosaurs passed on. These birds are meant to fly. Their bones are hollow, their feathers locked together. These birds were meant to rule the skies. But on a low-gravity planet, this is what you would see that would rule the planet.
Because gravity is going to be light, flight is going to be very easy. And flight is something that's been done on Earth by a number of organisms in different ways. Bats stretch membranes between their fingers and create wings to fly. Flying squirrels put flaps out of their fur and glide that way.
But not everything on GPC 925 is comparable to creatures on Earth.
The strangest of the airborne creatures one could imagine are the loligars. Imagine floating sacs that almost look like inflated lungs, with long, long, long tentacles hanging down that drape along the countryside as they slowly move and float over the scenery. Heated by internal heat inside, the warm air inflates their sacs. They almost look like jellyfish floating through the air. And like jellyfish, they sting and grab anything that scurries over the ground in front of them. To see them moving, bobbing up and down in the wind like a herd of psychedelic jellyfish is something beyond what we can imagine. And yet here, it's quite common.
Even life on the ground would push the limits of science as we know it.
When we take a look at this world, think of the sway stacks. They look like they are long stalks that extend 15, 20, 30 feet into the air. Numerous ones coming up with a bulb on the end. They sway in the wind, but what's amazing is these aren't plants. These are animals, with roots that pick up and slowly move across the planet's surface and anchor themselves back down, swaying in the wind with a wait for any creature that happens by. As the creature moves by, the top of them, like little frisbees, shoot off and wedge into the side of the creature, into their leg, into their carapace, into their hair, stuck for the moment. As they move on, they reach a new area, they drop off, and they begin growing all over again. They're simply spreading their seeds with these tiny little discs flying through the air once they sense something moving by. On this planet, we see similar things with the plants and the weeds that grow here, but nothing to this size and extent. And the idea that we begin crossing plants that look like animals and animals that look like plants, this is a bizarre world indeed.
Creatures like the sway stacks and the loligars would enjoy an adequate amount of water on GPC 925. But what would happen on a world where there was even more water? A lot more. Specifically, a planet with no land whatsoever. A water world. Since we embarked on our intergalactic safari, we have seen the amazing life cycle of the ACOM on Arenal, the bizarre-looking Pholus on AG-143, and the floating loligars of GPC 925. All of these theoretical life forms on these imaginary worlds have been created by scientists based on knowledge about the development of life on Earth. But how would these creatures have gotten their start on these strange, far-flung planets?
The requirements that we know have to be there for life is based on the life that we know. And the chemistry that we think leads to the origin and evolution of life is carbon chemistry in aqueous or water solution. So we need liquid water, we need carbon, and we need nitrogen.
And you need some sort of energy, because life, even microbes, needs food. They've got to have some sort of metabolism, so you need some source of energy. Sunlight works pretty well, but it isn't the only source of energy, even on Earth.
For hundreds of years, scientists believed that sunlight was the only energy source for life. But within the past few decades, new findings showed they were wrong. Boiling water temperatures found around hydrothermal vents on the seafloor were once believed to be incompatible with life. But recently, scientists have discovered the areas around these black smokers are perfectly suitable for a flourishing underwater community. Instead of the sun, these creatures take their energy from the heat, gases, and minerals spewing from the vents. These highly tenacious life forms are known as extremophiles.
The existence of extremophiles broadens our aspects of what we think organisms can do and what we know organisms can do. In other words, if you look at all of the different kinds of environments that we find here on Earth, it ranges from extremely cold to extremely hot to acid to alkaline. Just about anything you can think of, and just about everywhere you find life.
The fact that life is found at all on Earth is due in large part to our position in the solar system.
We scientists used to believe that in order to get life off the ground on a planet, it has to be in the Goldilocks zone of the sun. Not too close, because water will boil, not too far, because water will freeze, but just right to have a liquid ocean out of which DNA can form. Well, that picture we now know is wrong. We now believe that even on icy moons of planets like Jupiter, it is possible to get life off the ground. Europa is the moon of Jupiter. It's covered in ice, but beneath the ice, there is apparently a gigantic ocean, perhaps stable for billions of years, containing liquid water.
And so that sent the physicists and so on scrambling. How could you end up with liquid water so far away from the sun? Now, what it turns out the idea is that there's something called tidal flexing.
For Europa, tidal flexing is caused by the immense size and gravitational pull of Jupiter, which causes the ice on the moon to pull and stretch, generating heat. Once the insulated lower layers get warm enough, the ice will melt, creating oceans. Now add the types of organic compounds that are believed to exist on Europa, and you've got a slightly altered but very realistic recipe for life. This brings us to our next stop in our intergalactic safari. As we leave the busy skies of GPC 925 behind, we can travel 72 light years to a theoretical gas giant known as Ynir G, a planet circled by 8 moons.
Normally, we wouldn't bother with Ynir G. It's a gas giant, and we don't think life could exist on these worlds. The world we're interested in is the moon Anarbas. It's about twice the size of Mercury. It's a world very similar to the moon Europa that circles around Jupiter. Imagine a planet covered with oceans, and on the surface, ice. A lot of ice that locks everything inside. There's no ground to walk on this planet. But inside these oceans, they could be teeming with life.
And with the constant pull by Ynir G, Honor Boss would most likely have a large amount of geothermal activity that could be a prime source of energy for life to begin. Near the surface on Honor Boss, small amounts of light may bleed through the thinner areas of ice to the water below. Here, some creatures may have evolved eyes. This may provide them with advantages, but would also make them vulnerable to certain defense techniques. One example of a cunning underwater escape artist is the Amabos.
To us, light is just light. But think of the Amabos, a small little, almost gelatinous-looking creature that swims through the water. Innocent. As anything comes close to it that threatens it, it throws out a brilliant flash of sparkling lights all around it, blinding whatever creature came up to it. And in that moment, it's gone. Much like a squid might shoot out a big ink cloud or an octopus underwater, it is suddenly masked by brilliant lights that almost look like the 4th of July. And it's gone. Light, in that sense, is a protective mechanism.
But creatures that live much deeper in the oceans would adapt other methods for survival. One example is the Zaualina.
The Zaualina look like a cross between a weird spider and a very strange crab. But they have an odd ability. They don't sense their worlds through eyes. They don't sense their world through ears. They sense their world through an electric field that they generate around their bodies. This field can be stretched out so that it senses everything that's moving around it. It sees its world by what impinges on this electronic field. And the interesting thing about it is, once they've locked on to something that they think is prey, they wait till it draws nearer and nearer, and all of a sudden, zap! Huge bolt of electricity jets out, stuns their prey, and a tentacle whips out and grabs it and pulls it right in. It hunts by using electricity.
As we see the immense challenges that creatures like this would have to overcome in a water world, there is one last factor yet to explore. When the time comes that the people of Earth discover life in the cosmos, or that life finally decides to reveal itself to the human race, it may not be a biological entity at all. Rather than flesh, blood, and carbon, we might be met with steel and silicon. A machine. As we approach the theoretical planet Galileo, our final stop, we notice 3 extremely large craters on the surface. An asteroid collision with a life-supporting planet would be catastrophic. But on Galileo, something's different. We approach the surface and see tiny mechanical creatures roaming around. Although our journey thus far has explored an imaginary edge of the universe filled with biological creatures of all shapes and sizes, some scientists believe an alien world could instead be a land of synthetic machines, much like Galileo. Dr. Seth Shostak of the Search for Extraterrestrial Intelligence, or SETI Institute, believes that when life beyond Earth is discovered, our cosmic relative may be made of steel and silicon rather than flesh and blood.
Any aliens that have gotten clever enough to build a radio transmitter and get on the air so that we could hear them have probably gone the next step. And the next step might be the development of thinking machines.
To better understand the origin of an alien planet teeming with these types of machines, scientists say we only have to look as far as our own evolution of intelligence here on Earth. Specifically, artificial intelligence.
Artificial intelligence, you might say, is the science of making babies from scratch instead of the old-fashioned way. It's the science and engineering that tries to put together a mind by understanding how the mind works.
Now, we haven't done that. We haven't built thinking machines, but people who work on that area seem to think that that's likely to happen within 20 years, 50 years, 100 years.
It's conceivable that hundreds, perhaps thousands of years into the future, we may want to merge with our machines. Realize that in the coming centuries, machines could actually become smarter than us. And there's always the danger that our creations will put us in zoos behind bars and throw peanuts at us and make us dance, just like we make bears dance at zoos.
But instead of merging with the machines, one day humans may in fact become the machines. And once the CPU surpasses the human brain, sophisticated software could give these beings an unparalleled advantage over us.
If you've got artificial intelligences running on brains 1,000,000 times faster than human and thinking 1,000,000 times fast as human, they can theoretically do 10,000 years worth of thinking in 3.5 days.
Vast amounts of energy would be their lifeline to achieving such a feat. Once they harvested Galileo for all usable resources, these small robotic creatures, known as Sevils, could build a planetary highway to space. Then the next level of machines, the Fishers, would have access to virtually an unlimited amount of energy for their survival.
Just realize that the Earth only uses a tiny fraction of the energy from the sun. If the sun were this big, the Earth would be nothing but a head of a pin compared to the size of the sun. So we absorb only the tiniest fraction of energy from the sun.
To harvest the energy from the sun, a theoretical structure known as a Dyson sphere could be built around it or any other star.
A Dyson sphere is a gigantic sphere that is built to surround a star to absorb all the energy from that star. In this way, you can absorb the entire output of a star without getting burned in the process.
Once a star is dissected for parts and its energy is depleted, the Fishers could dismantle the sphere and propel themselves towards the next galactic battery. If scientists are correct, this rise of the machines may even happen on a planet closer to home. As each year passes, new scientific findings are being made that push the envelope in understanding not only ourselves, but life in the universe. There is a whole new world, or rather worlds, ready for us to discover out there. And if life elsewhere in the universe is finally discovered, the sheer number of stars assures us that there is a diverse, colorful, and vast array of life to be found, and more alien faces than anyone could ever imagine.